From Dwight D. Doggyhauser and Chester Copperpup to Gabriella Von Gooey III, Bart W. Griswold, and Bad Leroy Brown. Good morning, good afternoon, good evening. I'm Jason Burns.
And I'm Danny Nucci, and this is were those all real dog characters?
Those are, the first two were my dogs that passed already, and the other three are my current dogs.
That's sweet.
Yes, I have. We have a monument of passing pets' ashes in our living room. That
in the mantle. Do you really have little?
Yeah,
urns?
it's like off to the side with their pictures and stuff like that. We've had some cats who have passed away as well, and So I plan on going wherever I'm going with all of them when they're over there. So
that's awesome.
I just had the most exciting text right before we started this interview, which is one of my favorite interviews we've done, is that my brand new glasses are available for pickup and I can go get them. Is there anything? Because my eyes have started to degrade just a little.
I don't think anybody called that. Nobody listening called that as the exciting text.
I almost said it to you, and I was like, "Oh my God!" As soon as we're hanging up, I'm going to get my new glasses, and I'll be able to see again. I'm so excited. Maybe Matt's future aging research will lead me not to get my next pair of glasses.
What an incredibly fascinating dude to research. I mean, I was blown away by it. And that's why I think it's one of our longer ones, because we told him we'd let him go like 8 questions. 8 questions before we actually let him go. I mean, what an interesting guy. He's a biologist. He's the co-director of the Dog Aging Project and an expert on aging and making strides and a wealth of information. Without further ado, Matt Kaeberlein.
Hello, sir.
Morning. How are you guys doing?
Where are you?
30 miles east of Seattle.
So you're in Washington. You're in the Pacific Northwest.
I am indeed.
Now, Matt, you're a biologist and a biogerontologist. The first one people are familiar with, but I have a feeling the second one a lot of people might not be. Can you explain the field and your place in it to start?
Maybe some people here.
Sure. Yeah. So I would say I don't know about biogerontologist, but that's as good a word as any. So I would characterize myself as a scientist who studies the biology of aging, and that's important, I think, because it's the biology of aging that really is what accounts for most of the functional declines and diseases that humans and other animals experience as they get older. So that's what I'm interested in. And I think that the biology is super fascinating, and the relevance to health and longevity is quite substantial.
So soccer moms aren't calling you for anti-aging tips?
I get all sorts of people calling me for anti-aging tips. You have no idea.
By the way, how do you feel about that term, anti-aging? The consumer catch-all phrase.
I have mixed emotions. It's not as bad as reversing aging. But I mean, I think from a scientific perspective, that's what we do, right? We're trying to find therapies that modulate the biology of aging in a way that will slow it down. And so that certainly could be defined as anti-aging. I think the unfortunate thing is that term has been co-opted by people who are interested in selling supplements or other types of products that are of unproven value.
As a society, Matt, haven't we already done that? Because the standard of living in terms of our age limits from medieval times to now is obviously quite different. So have we already done that?
No, in fact, that's actually a really interesting question. So if you look at maximum lifespan, 3,000 years ago, there were people living into their 90s, even over 100 years. Those were usually the aristocracy or philosophers, but we have probably done nothing to the underlying biology of aging in that context in 3,000 years. What we've done is increased average lifespan. Mostly that's been by things like sanitation, antibiotics, better nutrition. So we have done a good job, I think, as a society at preventing people from dying early due to things that are probably unrelated to the biology of aging. And then I would say in the last 50 years, what we have done is a good job of keeping sick people alive. If you look at the frequency of age-related chronic disease, it's actually gone up quite dramatically. It's sort of shocking, actually. The CDC estimates that 60% of Americans have at least one chronic age-related disease.
What separates an age-related disease from other diseases?
I think the easiest way to think about it is if you just look at the risk of developing the disease as a function of age, it goes up exponentially as you get older, and especially once you get past peak reproductive years.
So like shingles, to be reductive, I guess.
Shingles is an example for sure, but also most forms of cancer, heart disease, diabetes, kidney disease, liver disease, risk of dying from infection. Those things all show this sort of characteristic.
Overuse, basically? We're talking about overuse?
No, I don't know. I mean, part of it sure is wear and tear that comes from damage that accumulates over time. It's obviously more complicated than that from a biological perspective, but that's certainly part of it. Part of it too is declining function of the immune system that then contributes to things like age-related cancers, right? A lot of people don't realize that all of us are getting cancers and curing ourselves of cancer over and over and over again throughout our lives because our immune system takes care of those cancers before they become a problem. But as we get older, our immune system is less able to do that. And that's part of the reason why you see a dramatic increase in cancer with age.
So is the focus in terms of aging the immune system in terms of making progress?
It's one. So if you look at what people call the hallmarks of aging, there are 12 of them. One of them is clearly centered around immune function.
I'm tired already.
I know, right?
There's 12 of them. I'm exhausted. Good. Sorry, go on.
This is a problem because about 10 years ago there were 9 of them, and we've added 3 to the list, and I'm sure that will continue.
Sure.
But yeah, I mean, I think immune decline is one of the major features of aging that contributes to a lot of the problems in complicated animals like humans and dogs, and but it's not the only thing. I think that there's always a desire to want to simplify, but the biology of aging is immensely complicated, which is part of the reason why I was drawn to studying it as a graduate student. And, it's good job security for those of us in the field because we've got a lot still to figure out.
Sure. Was that part of what made you decide to do it, or were you just interested in the topic?
No.
Did you just have forethought, or you're like, hey, listen, this is going to take a minute?
I wasn't thinking that far ahead. So I was in my late 20s probably when I first got interested, and it was really just the complication of the problem. And then obviously aging became more personal as I, went through my career. And so now I'm also very interested in, what can I do for myself and what can I do for my dogs, right? That's a big part of what I work on as well.
Well, and we should probably tell everybody that you're 165 years old right now. So that but seriously, Matt, going back to what you were just talking about with age-related cancers. Now, if I watch the news, I'm hearing that cancers are hitting people younger and younger and younger. Does that further complicate your work?
I don't think it complicates our work. I think that there's some truth to that. And I think, one of the challenges with any biological research on humans is that the human environment is changing quite dramatically, right? Even the world we live in today is very different than the world we lived in when I was a teenager, right? So all of the things that people are exposed to, all of the microplastics and things like that are present in the food that we eat, the water we drink, changes the experience from a biological perspective that human beings have. And so it's hard sometimes to know, if we see an uptick in cancers at younger age, is that because of changes in the environment? Is it because of something else that's going on? But the reality is still the vast majority of cancers are age related. And this is one way I like to think about it is if you look at the impact of risk factors that people talk about for cancer. Let's just talk about cancer. We could do this for every age-related disease. Let's just talk about all cancers. Smoking increases your risk something like 2 to 3-fold, okay? If you go from age 45 to age 85, the increase in risk is like 100-fold. So the risk from biological aging is orders of magnitude higher than any other single risk factor you could imagine. Even if more people are getting cancers when they're young, still the vast majority of cancers are caused by biological aging.
So is part of what you look at, you hear about, and I'm going to blank on the names, but they're the zones where people live to an extended period of time.
Blue zones.
Yeah. So do you study those zones as part of your research?
I don't. Other people do. And I think there's value in studying those. One of the challenges with the blue zones, of course, is that it's very difficult in some cases to document whether the people that they claim are living to be 105 years old are really living to be 105 years old. The one blue zone that I think is rock solid is Okinawa, which is the island off of mainland Japan. And, there's pretty good evidence that the Okinawan Japanese probably achieve their exceptional longevity through both the composition of their diet and the amount of their diet. So Okinawan Japanese ate about 15% less calories total than mainland Japanese and lived, I think it was probably 5 or 6 years longer on average for many, many decades. Interestingly, I'm told, I haven't actually seen the data, but I'm going to say it anyways. I'm told that this difference in life expectancy in Okinawa has since gone away since McDonald's was introduced to the island. So, there you go.
Oh my God, that's hilarious. Makes sense.
I remember seeing a gentleman on the Tonight Show back in Johnny Carson days who was like 100 years old. He ate a Big Mac every day and he was healthy as a clam.
Yeah.
So, but there's always those exceptions, right?
Right. Yeah. So, there are people who study centenarians. So centenarians are humans that live past 100 years old. And there are scientists who study centenarians. And again, my reading of that literature and from talking to these scientists is their centenarians fall into two classes. There are the people who are that old and have many of the same functional declines and diseases we would expect. And then there are the people who are really healthy. And often the people who are really healthy have not lived a healthy lifestyle, right? So like Jean Calment, who is the person who is recognized as being the longest lived human being ever, 121 plus years, 122 plus years. She, I think, smoked until she was over 100 years old. And the
my kind of gal.
Yeah, at least the story is the reason why she stopped smoking was because her hands shook so much and she hated to ask anybody to light her cigarettes for her, so that's why she stopped, right? So you hear about these people who lived exceptionally long time and had what we would consider poor lifestyles, and the biological hypothesis is that they had the genetic makeup to be resistant or resilient to the damage that would normally cause disease or kill a typical person. So centenarians seem to fall into two classes, and there are those people who just got the luck of the draw apparently, and have a genetic makeup that makes them resilient. And understanding that genetic makeup obviously would potentially allow us to figure out how to mimic that in the rest of the human population.
But has there been, and I know not specific to your research, but has there been research to those centenarians who lived their lives the way they wanted to live and their future family tree, and if they are living just as long as?
Yeah, as you can imagine, those kinds of studies are more challenging because they take a long time in humans, right? We're talking multiple generations. But yes, the answer is that offspring of centenarians tend to live longer than their spouses, right? Who presumably the spouse's parents are not centenarians. And from that, people have tried to estimate like how much of the human longevity is genetic versus environmental. And again, environment captures everything else. So that would be diet, air quality, water quality, whether you exercise, everything that's not genetics would go in the environment bucket. And it turns out that it's a little bit hard to know for sure, but I'd say about 20% of human longevity is genetic and the rest is environmental. So there is an effect. But the good news is that you can actually control most of it by modifying your environment. Now, the hard part is we don't necessarily know exactly how to modify the environment to give ourselves the best chance of living a long time. And the things we do know about, most people don't want to do, right? Like eat a healthy diet and exercise regularly. Yeah, exactly.
Such as?
Yeah, So this goes into like a more personal for you territory, Matt.
Sure.
But as somebody who studies aging and longevity, do you worry what is after? Like, do you worry, like, is part of your research the ability to make hair count for as long as possible?
Well, I'm not sure exactly what you're asking. Are you asking like, am I worried about what comes after this human existence? Not really.
Yes.
No, not really. I mean, so my personal sort of journey is I was raised in a very religious family at an early age. I kind of recognized that I had questions about that. So I would characterize myself as an agnostic, and I'm not too worried about things that I can't control and I know that we can't answer. So, whatever's after this is after this. And I'll deal with it when I get there.
Cross that bridge when we get there.
Exactly. No, that's exactly right. That's exactly right. But I do also feel like, look, wherever you fall on religion or not religion, I sort of feel like I am living my life to the best that I can, to be a good human being and to try to help other people. And that's about the best I can do. And that makes me feel good. So it's sort of selfish, but that's how I live my life. And so I'm not going to worry about what comes after this. I'm going to try to make the most of what I've got while I'm here.
But it does bring up the question for me, in terms of, living longer. It's also just having more quality of life. I mean,
Absolutely.
The idea of being 95 years old and being able to move like most 95-year-olds is not an attractive prospect for me. But there are those that are outliers that are, sharp. And I mean, Norman Lear, sharp right up until he was 99, I think, or 100. Yeah, 99, I think, yeah.
So you're hitting on this idea of health span, right? And I think that's what many of us in the field spend a lot of time talking about because of what you just said. Most people, when they immediately think about living a long time, they think about living longer as somebody who's old and not having the quality of life that we all would want. I think what we all want is to maximize health span, the healthy period of life, for as much as possible. And I mean, I think the easy way to think about, like, you can have complicated definitions of health span. I would define health span at the simple level as just being able to do the shit you want to do, right? Because that's what we all want. We want to be able to live independently and do the stuff we like to do with the people we like to do it with. So that's what's most important. And we know that's possible. There's some luck involved, but there's a lot of things that people can do to give themselves the best opportunity to maximize health span. And I think the thing that is nice is we are learning how the things like quality diet and exercise and sleep quality are actually impacting the biology of aging. That's why those things prevent a whole bunch of diseases and maintain function longer.
I think people, all have a sense of those things, and also, and also just in terms of your general disposition in life, how happy you are, what you're, how you mostly feel most of the time, I think is also impacts that as well. But I guess what I wanted you to touch on is which in each of those areas, which things have you found in your work that which faction of those things seems to be the most impactful?
Are you talking about lifestyle factors in particular?
Yeah. Well, and then the three that are, I think there's, they're all $3 billion industries.
So
right?
I think obviously there are lots of people out there talking about longevity right now, and they all have different numbers of pillars and whatever.
Creams and pills, yeah.
No, not pills. Not everyone has pills.
No. I'm just kidding. I'm just.
We can talk about pills. There are, that's an interesting area too. But I sort of think about it in four pillars. There's nutrition, eat. There's exercise, move, sleep, and then connect is sort of the one that is a little bit more nebulous, but it has to do with both your personal sort of mindfulness, connection to yourself, and interpersonal relationships. Those are, I don't know which one's most important, but they're all important. I think that, for different people, different pillars are going to be more important. And, it's a generalization, but for men, especially middle-aged men, it's the human connection pillar often that is the hardest one to actually make progress in. And that's for me personally as well.
It's the only one I got. The other three, I'm dying.
Oh, you're good. Good for you. As long as we've all got one, we can lean on, right?
What's interesting for me, Matt, is like, that's my biggest fear about growing old. If I live to 100, I'm going to see all the other people I love leave the world.
So I hear you. And I mean, I don't have an answer to that. The one thing I will say is I've sort of been on a personal health journey for the last 4 or 5 years. And my personal health has gotten a lot better. And it's my experience that when you start to take control of your own health and learn about your own health and talk about it, there's a network effect on the people around you, right? So, and I've seen this with lots of other people as well. All of a sudden, spouses, parents, friends are learning and responding. So, I mean, I'm not saying that's going to fix the problem of worrying about or potentially being alone when you get older, but
taking the worrying out of it, I guess what I'm saying is from your research, if you're looking at expanding the lifespan of humans, do you have to also look at the loneliness of that if we get to those higher ages?
I mean, I think there are a lot of societal issues that come up if when you talk about potential success in this area. So, I mean, we kind of got off talking about lifestyle factors, and that in some ways, I mean, that's what people already know about. I think what you're pointing to is if the science gets to the point where we then now have therapies, and I think we're not so far off. We now have therapies that might, for some people, increase healthy lifespan by, let's just say, 15 years, right?
Mhm.
That's a pretty big impact.
It's an expensive impact. That's 15 more years. I got to have money.
Well, I mean, again, so you guys keep bringing up new topics, right?
Sorry. We're all over the place.
The economics of this is actually pretty interesting as well, from both a societal and a personal perspective. But I think one question is, will everybody get access to it, right? Or will it be only a select few? I mean, who knows, right? These are complicated questions, but I do think that these are things that society should start thinking about now. Like I said, personally, I don't believe the science is so far off from that possibility. And there may be things we know about today that actually would have that kind of a magnitude of effect. So I think these are things that we really should be talking about and thinking about, because there are all sorts of very complicated issues that arise if only a subset of people get this, if many people get this, if everybody gets this. The impacts on society as a whole are going to be complicated, and nobody's really thinking about that. The impacts on healthcare are going to be complicated. We haven't even talked about healthcare. Healthcare is a mess. I mean, it is just broken. And
okay, now you're adding subject.
Medicare, Medicaid.
So I want to come. The fact is, I'm just personally, I'll speak for me. I'm just very excited to hear, to talk to you and get a sense of what your experience is, because it's important. So if you want to go back to the in terms of the specific things that can help in the three areas we discussed that weren't sort of connective, I want to give you an opportunity, and also because it led into your own personal journey the last 5 years, and I wanted to give you an opportunity to express that.
Sure. So there's a couple of buckets I would talk about. One independent of the lifestyle stuff is just, this is alluding to what I just mentioned about healthcare being broken. I think one of the most important things people should do is become educated about their own health and not rely on their primary care doc to take care of them, because that's not going to happen in most cases. So you really need to become proactive and learn about, how to advocate for yourself within the current healthcare system. There's a lot of really simple stuff that doesn't get done in primary care that should get done for everybody. And I'm talking about preventative screening, vitamin deficiencies. I mean, it seems obvious, but most people don't know about this. So that's one thing I would point to. That's been sort of my experience and my learning. And look, I was in this field doing research on the biology of aging for 20 years before I actually started taking care of myself. So I'm sort of also fired up about this, as you can tell.
What prompted that? I'm sorry, I don't mean to interrupt you, but what prompted that a little bit?
I think it was a combination of the pandemic and sort of, I think a lot of what we all went through. For me personally, that had an impact. And it was also getting to know some people who had been sort of thinking more on the medical side about proactive preventative healthcare, and learning from them, how little of that I actually received, right? So, and also I turned 50, and so that has a role as well, right? I think it was a combination of factors. So anyways, I think that's one thing people should pay attention to. The other, and then we can talk about specifically for lifestyle, like I think diet is complicated. I'm certainly not somebody who is going to say there's a one size fits all. I think you should try different things and kind of figure out what works for you. The really simple stuff is cut out the processed crap, cut out the simple sugars. And, the one that most people don't want to hear, but is true, is cut down or cut out the alcohol, right? And for me personally, that was a big one. So, I think like a lot of people in the pandemic, I sort of fell in this trap of drinking every day, right? And in hindsight, I can look back on that and say, well, that was not healthy. And I have my wife to thank. At some point, she was like, you know what? We're just going to get all the alcohol out of the house. We're not going to drink anymore. And that's been a game changer for us. So I think a lot of people struggle with alcohol, but that's a big one for a lot of people.
As a scientist, I wanted to touch on that processed food, Matt, because it feels like that the more we learn is that's becoming like the next asbestos or lead paint, the things that we are a part of our society and then one day will no longer be a part of our society.
Yeah, especially, and this is where I think the definition of processed is a little tricky. So there's the highly processed foods, but I mean, I think that there are especially these highly processed foods that are so ubiquitous. And I think what we're learning is that they create problems in multiple ways. So they have chemicals and molecules in them that are detrimental for our bodies, but they also affect our metabolism in a way where they are not satiating. In fact, they drive people to be more hungry. So you not only are eating low quality food that potentially has toxins in it, but you're eating more of it, which is driving the obesity epidemic. So it's kind of like a double whammy. And I'm not one of these people who's like, this is a big conspiracy by the food companies. I don't think that's the case. But I do think it was sort of an unanticipated consequence of this processing that goes into the food for a variety of reasons to make it cheaper, to make it last longer, that we're learning is really, really bad news. And so, unfortunately, the high quality food costs more. And there are a lot of people who simply can't afford what I would consider a high quality diet. And so we've got this situation where, that's contributing to the healthcare disparities. But I agree with you. I think 20, 30 years from now, we'll look back on this and be like, I can't believe people ate that shit. I hope that's where we get to, because it's really bad news for a lot of people.
What about dog aging?
Well, Matt, I am not a huge fan of humans, but what I am a huge fan of is canines. And so, which is why we're talking today on the grander scheme of things, which is dog aging. And I think before we get into that, we first have to talk about your relationship with dogs and what they mean to you as a person. If we could start.
Yeah, so I've always had dogs ever since I was a little kid, and as an adult, have had multiple dogs. I have one German Shepherd now. His name is Dobby. He's almost 14 years old. I love him to death, and we're just celebrating all the time we have left with him.
14. How's his hips?
Yeah, so it's really interesting. So he's doing okay. So we went through a period about 6 months ago. So he does have some degeneration in the hind legs, and we went through a period about 6 months ago where we really thought we were getting close to the end. And I was very fortunate to be able to get him a therapy that at that time wasn't on the market yet, is now on the market for blocking the neuropeptide pain signaling response. So there's a monoclonal antibody therapy. It's done wonders for him. And he's doing great, at least compared to how he was doing before. So, sure. But he does have the hip degeneration, and big dogs especially are prone to that. But to answer your question, I mean, I'm somebody who, is a dog person. And so I recognize, why it is that more than half of people who have dogs consider them part of the family. I definitely consider and have always considered my dogs part of the family.
So what came first? Was it the human aging element that interested you, or the canine aging?
Yeah, I mean, so again, just to take a step back, 20 plus years ago when I was a graduate student, I was really just interested in the biology. And again, I was young enough, I didn't think about it personally. And we were studying at that point was far enough removed, at least in my mind, from ever getting to human use, that it was really more about the complexity of the biological problem and the fun of trying to solve a mystery, recognizing that, sure, someday in the future, maybe this could have huge impacts on health because, as we've already talked about, age is the greatest risk factor for a bunch of different diseases. And it was about 14, 15, maybe not quite that long, 13 years ago that I was talking with Daniel Promislow, who's the co-director of the Dog Aging Project with me. And he'd been interested in dogs as a model to understand the biology of aging, because pet dogs especially live in the human environment. They age 7 to 10 times faster than people do. They're a very powerful animal in which to study the aging process. And through those conversations with Daniel, I realized in my head, we know about these things in mice that can increase lifespan by 25%. We're doing these experiments in my lab. Mice aren't that different than dogs. I might be able to increase the lifespan of my dog and other people's dogs by 25%. And when that light bulb went off, I was like, holy shit.
What a service that is,
Yeah. Well, not only that, but I was like, yeah, I mean, exactly. I was like, viscerally inside, I was like, I have to do this. I mean, this will work. I don't know if rapamycin, which is the drug we're testing now, is going to have that effect, but there is no doubt in my mind something that we are studying now in mice will increase lifespan and health span in dogs.
What is 25% of a lifespan in a mouse? What is that, like time-wise?
That would be about 6 months, maybe. Okay. So mice Yeah, mice typically will live 2.5 to 3 years in the lab. So we're talking, significant.
So you're talking another 4 to 5 years in a canine.
Depends on the dog. I
Depending
mean,
on breed,
again,
yeah.
I think we have to be careful not to extrapolate percentages, necessarily, maybe. But yes, if you
We want percentages. We want facts. God damn it.
I want my dogs to live forever, Matt. Come on.
we have to, yeah, I am definitely not the dog immortality guy. So if that's the guy you want, you got the wrong guy. I mean, I would like that, but I'm not going to promise it. But I would say, yeah.
So what's fascinating here is that when you said when you started out, when you were in the beginning part of your career, you thought this was never going to be a reality that you saw, but you're saying there's a chance you're going to see it.
Yeah, I mean, we're doing a clinical trial right now where I think, when that trial's done, the answer will be yes or no in terms of lifespan, but I think there's a pretty good chance the answer is going to be yes. And I think given the number of different interventions we know can impact the biology of aging in laboratory animals. And now, because of what we've done at the Dog Aging Project, we're starting to see companies move into this space and try to develop other therapies to target the biology of aging in pets. Yeah, I am confident that we will see interventions, drugs, other types of things in the market at some point in the next 5 to 10 years that can increase lifespan and health span in pets. Yes.
Well, and you talk about the medical community. I work 1 day a week as a vet tech.
Oh yeah, cool.
And the vet industry is a little broken as well. How do you get the doctors and what is basically a number of companies that own all the vets now? A lot of people don't know that is there's just a few owners of everything now. How do you get them on board?
I mean, I think the way you do it. So the cynical answer would be you market the hell out of it, right? And there are supplement companies doing that. I'm not involved with them. I don't, I wouldn't suggest that you listen to people who claim they have an anti-aging dog supplement right now. I think that the real answer is you do rigorous clinical trials. If you're a company, you get FDA approval. I think veterinarians. So in general, I think veterinarians, like most medical doctors, really want to do a good job for their clients and for the animals, right? And so if you can convince them that you have done good science and you've done rigorous studies and you have something that is safe and likely to benefit the animals, veterinarians will get on board. Maybe that's idealistic and naive, but I believe that will be the case. And I will also say it's been my experience that veterinarians are less conservative than most medical doctors and are more willing to accept this idea of targeting aging directly. So here, this is probably worth just mentioning explicitly. One of the challenges in this space for humans is most MDs are trained to be very conservative and this idea of do no harm, right? And so that means that they think of a typical 70-year-old who's got all sorts of problems. They think that, well, that's normal for a 70-year-old. We shouldn't do anything unless this person has cancer or kidney disease or whatever, right? What they don't consider is the consequences of doing nothing, right? Of not intervening. We all know how that story is going to end if we don't do anything. And so there has to be this mindset shift. And I think veterinarians are more easily adopt that idea of prevention and targeting the biology of aging to keep animals healthy, in part because they haven't been indoctrinated in this super conservative sort of training. And because in dogs, especially, we can see the aging process play out in real time. And so the idea that we could actually impact that and slow the aging process in dogs, I think veterinarians are more likely to adopt therapeutic approaches than medical doctors, at least in the short term.
Well, and 20 years ago, we weren't giving every dog heartworm medication, but we are now. So the industry accepted that.
Right.
So we kind of touched on this too, Matt, but a dog's lifespan greatly depends on the breed and the size of the dog. Does that studying what you're doing does that make it more difficult or easier because you can put them into quadrants?
I don't know that it makes it more difficult or easy. I think we know that the main determinant of body size in dogs is a pathway or a factor called IGF-1, insulin-like growth factor 1. And the interesting thing there is, so big dogs have higher IGF-1, that gives them a larger body size, and big dogs age faster than small dogs. We know from mouse studies that if you take a mouse and you cause it to have low levels of IGF-1 through development, it will be smaller and it will age slower. So that's probably the biological mechanism that causes big dogs to age faster than small dogs. So that's kind of cool. It tells us that biology of aging is conserved. And for our clinical trial, we are taking advantage, in a sense, of this difference in body size and aging rate to allow us to do that clinical trial in a shorter period of time. So for our trial of rapamycin, we are only enrolling dogs that are more than 40 pounds. And the reason we're doing that is because dogs above 40 pounds are aging faster than dogs below 40 pounds, which means we can see an increase in lifespan, if there is going to be one, in a shorter period of time. So we're actually taking advantage of that difference in aging rate to shorten the amount of time for the clinical trial.
So when a parent wants to buy a dog for their child, are they going to be? Is there going to be epigenetics for the dogs? Are we going to be looking? Are we going to want answers that are specific in terms of the dogs?
Maybe. I mean, so again, I just told you, like, it depends on what you want in a dog, right? I'm a big dog guy. I love big dogs. It sucks that they age so rapidly. But if you want a dog that's going to live a long time, get a small dog, right? To answer your question about epigenetics, I don't know that we'll get to a point anytime in the near future where people will be like going to the shelter and picking the dog based on its epigenetics. But maybe. I mean, I don't know. But so first of all, that biology of measuring the epigenetics works in dogs the same way it works in mice, the same way it works in people. There are companies developing epigenetic tests for dogs that will certainly predict the dog's chronological age. Those already exist. And I think the expectation is it should be possible to generate epigenetic tests and other types of diagnostics that will predict mortality risk, specific disease incidents, things like that. So those will be on the market, and presumably some people will use them, maybe use them to pick their dog. I don't know how I feel about that. I've honestly never really thought about that.
Well, that's I bring it up because we just want this as a society as a whole, and including everything that's going on now. We're just so thirsty for certainty about everything, even though life isn't like that. And that seems to be the thing that gets in the way, which is why I really appreciate you and the study that you're doing, which is you seem so open to the uncertainty of it and what it's going to reveal, which was one of the things that I really appreciated about when I was looking at your stuff. But that's why that's like a concern for me. So we're trying to measure everything in a predictable way, and that's not how these things work.
Yeah, and I think especially with a lot of the epigenetic tests or the biological aging clocks, and there's a lot of people now in the biomarker space, and I think they don't really understand what you just said, which is that none of these biomarkers have a lot of certainty around them. They're all associated with different things, but there's a lot of error in those associations. And my real concern with the commercial tests that are being sold is these things work as a research tool, but these companies that are selling these tests have not provided any evidence that they are precise, that they are accurate, that they are really measuring anything useful. And so, yeah, I mean, I think really it's wanting certainty. I think in the longevity space too, there's this fear driven desire for control, to do something, right? And so a lot of people are so desperate to do something about aging that they're willing to grasp on to all this snake oil and all this nonsense. And that's really, I think, driven largely by fear and uncertainty.
Mm-hmm.
Can I ask you a stupid question, Matt?
I get them all the time. Go for it.
All right, good. So if we apply this to the human side of what we discussed already, in the future, if we are living another 20 years, are we going to be smaller as a society?
Oh, like, is it going to affect body size?
Yeah.
Yeah, that's an interesting question. I don't know is the answer, obviously. So here's an interesting, though, twist on that, which is that one of the companies that's working in this space in dogs is a company called Loyal. They've gotten some press recently about they're going through the FDA approval process for their first drug. Their first drug targets this pathway. It targets the IGF-1 pathway in dogs. So their hypothesis is that we can give this drug to middle-aged dogs, turn down IGF-1, and it will increase lifespan. Will that also reduce body size? Probably not much. I think you have to turn that down during development to impact body size. And so the question is, will it give this impact on lifespan? We'll find out in the next 5 years as they go through this process. I don't have any data to really answer that, but
because it's just interesting, because as a society, decades and centuries ago, we were smaller. If you go to Fenway Park now,
but we were smaller for different reasons, right? So and this is where it gets interesting from a biological perspective. If you turn down growth signaling during development in every mammal that I'm aware of, so mice, dogs, humans, you will get smaller individuals, and as long as those individuals have good nutrition, they will be smaller and live longer. They will age more slowly. But you can also stunt growth through poor nutrition, and that is not going to be associated with slower aging and longer lifespan. So I think the answer is, this is speculation now, but I think the answer is yes, you could slow aging in humans by turning down these growth signaling pathways during development. You would get smaller humans who live longer. And there was a study done by Walter Longo on people who have growth hormone deficiency. So these are these little people. They live in a community, I don't, somewhere, I think in South America somewhere. So he studied them, and it's interesting. So they don't live longer, but they don't get any cancer. They have much lower rates of metabolic and heart disease. They die more predominantly from alcohol and accidents. So they may actually be aging more slowly. And this is where humans are complicated, because there are social consequences to being smaller as well, right?
Yeah, sometimes we're our own worst enemy too.
Many times. I would say that's actually the rule rather than the exception, unfortunately.
In terms of biology and looking at size, whales are big, but they have long lifespans.
Okay, so yes, this is a source of much confusion. So when you look within a species, so if you only look at humans or only look at dogs, it is generally the case that smaller individuals age more slowly and live longer. And that's probably growth hormone IGF-1 related. When you look across species, so now we're looking across the whole animal kingdom, large animals tend to live longer. And there are some outliers, but that correlation is pretty darn strong. And that's probably because large animals, first of all, have more cells. So you have to have potent anti-cancer mechanisms in order to get to reproductive age. And large animals tend to reproduce later in life. And so if you just think about this from the perspective of evolution and natural selection, those animals had to evolve to age more slowly and to get less cancer in order to be able to reproduce and pass their genes on to the next generation. So that's probably the explanation there. But yeah, big animals tend to live longer, but within a species, smaller individuals tend to live longer.
Got it. Okay.
Jason won't ask this question because he doesn't want to sound silly, but I'm going to ask it because I don't care. Demystify the dog age myth.
So first of all, as a sort of like rule of thumb, I actually don't think it's that bad.
Oh, the 7 years per...
There you go.
But as we've already talked about, first of all, big dogs age faster than small dogs. And there's about a twofold difference there. So it's going to depend on the size of the dog. The thing that's super interesting about that rule is, that's why I said 7 to 10 years, by the way, earlier. It really depends on the life stage of the animal. So if you could, and people have done this, if you look at epigenetic age, for example, and you plot humans on the y-axis, sorry, I have to get a little bit mathematical here.
Go ahead. We're good. We're following you.
If you plot humans on the y-axis and dogs on the x-axis, and you try to plot their biological or epigenetic age, at the beginning of life, dogs are aging like 15 times faster than humans are. And then when they get to reproductive age, it sort of tails off. So by the end of life, they're only aging about 2 times faster than people are. So if you average that across the entire life, it's about 7, but it's not constant 7 the entire time.
Okay, so another tough question, and this applies to human and dogs. So my dog went gray really young. I went gray really young. Doesn't that somehow, like, people talk about biological age and all that? Does it have anything to do with anything?
I mean, it has something to do with something, but I wouldn't worry about it, I think, is the answer.
There's other things to worry about.
Yeah, that's right. There's lots and lots of age-related changes, right? And this is also related to this idea of reversing aging. So I actually think this is a nice segue to that. There are many things. There are thousands of things that change across the population with age, where most people develop these changes. Some of them are fundamentally related to the biology of aging. Some of them are just superficial. And I think gray hair is a superficial change. Just like if you took your gray hair and you dyed it black, you've reversed that age-related change, but you haven't reversed aging, right? No reasonable person would say that you have reversed aging simply because you dyed your hair. And so this is the challenge, though, is now we have some pure charlatans, and we have some people who have some at least credentials out there claiming that they have reversed aging by changing one thing or by changing a small number of things. And so I think that's just dishonest in my view. But I think it is an interesting question. Like, how will we know when somebody has actually reversed biological aging at the whole organism level or at the organ level? And I don't know the answer to that, but I kind of feel like at the whole organism level, if you show me that you can take an old dog and make it young again, or take an old mouse and make it young again, I'll believe you've reversed biological aging or you've reversed aging. Until you do that, I'm going to be very skeptical when somebody says they are making an animal age backwards. And it just blows my mind how many people are not skeptical of the claims that animals or people are aging backwards. It's just ridiculous to me.
We've seen too many movies. That's really what it is. Can you talk about the dog aging project, how it came up, and how people can get involved?
Sure. So let me start with how people can get involved. The website is dogagingproject.org. There is a little button up there that says, I think, nominate your dog, and click on that button. And we want dogs of all sizes, shapes, sex, breeds, ages for the study. And let me just clarify, because we haven't talked about it. There's the clinical trial piece of rapamycin. That's only about 500 dogs. The rest of the study is an observational study. We're not asking owners to do anything different with their dogs than they normally would. We're collecting data on those dogs. For most of the dogs, it's just survey data and medical records. For a subset of the dogs, we're sequencing their genome, asking owners to take a kit to the veterinarian to collect blood and doing biological sampling. But yeah, any dog in the United States.
So they can get involved in any aspect of it that they want.
That's right. You don't have to be in the clinical trial, and your dog doesn't have to take rapamycin. Okay, so how did it get started? This, again, I sort of alluded to this. For me, it was about 13 years ago when Daniel and I were both directing a summer course at Woods Hole on the biology of aging, and we started talking about dogs and his interest in dogs as a model for aging. And I sort of had this light bulb moment. I was like, I have to do this. And so I went out and started trying to scrape together money, and it was really hard. It was really hard to convince people that this was something that could be done. Everybody was like, oh, that's a great idea, but there's no way you're ever going to be able to do that. So it took us about 5 years to really get the first large NIH grant. I raised enough money that we could do 2 small clinical trials with rapamycin to do proof of principle that we could get owners to participate and the drug was safe and all of that. But it really took us until 2018 to get the first NIH grant. And that's what allowed us to build the Dog Aging Project into what it is today, which now has, 50,000 dogs and owners participating in this huge community science open access project.
That's a lot of data. I mean, here's a question for you. Because Danny and I are from the creative space, AI is kind of a negative word. Is AI helping you in any of your research and moving the ball forward, so to speak?
The answer is yes. I mean, already ourselves and other people are using some of the AI tools. These biological aging clocks were largely developed with AI-based tools. So absolutely, AI has moved the field forward, and I think it will continue to move the field forward. I'm certainly not one of those people who subscribes to the idea that AI is going to figure out aging or cure aging, but I think these tools are in fact becoming much more powerful and much more useful, and will continue to become much more useful. I honestly think the people who are going to be best positioned in the future in research are not going to be the people who are developing the AI. It's going to be the scientists who know what the tools are and how to use them. But absolutely, I think it's definitely going to accelerate the rate of discovery in the field. Obviously, there's lots of ways that AI can be used that are negative and detrimental as well. But I think in general for biological research, the opportunities are quite powerful.
Before we let you go, we have a listener question. Thank you, by the way. And Divine G, great name, Divine G. I like dogs, but I love cats. Will your research one day apply to our feline friends too?
Yeah, that's a great question. So I get asked a lot, especially when it comes to rapamycin, like, why are you doing this in dogs and not in cats? So with rapamycin specifically, there's no reason, first of all, to think that the biology of aging in cats is very different from dogs. So the answer is yes. I think most of what we learn about aging in dogs will equally apply to cats. For rapamycin specifically, the reason why we picked dogs for the clinical trials, one, I like cats. I've had cats. I'm more a dog person than a cat person. And number two, have you ever tried to give a pill to a cat? So the owners have to give the pill to the dog once a week.
Practicality wins again.
But having said that, it's very cool. Since you brought up cats, there's a company called Trivium Vet that makes a veterinary formulation of rapamycin. That's actually what we're using in our clinical trial. They have shown And I think they're working on FDA approval. It's close. They have shown that they can reverse hypertrophic cardiomyopathy, which is a specific form of heart disease in cats with rapamycin. So I think that product will actually be on the market soon, and that's a really big deal because I don't think there's anything unique about hypertrophic cardiomyopathy. I think that that's because rapamycin is actually impacting the biology of aging. So the short answer, though, is that cats don't age quite as fast as dogs do, but the biology of aging is so shared, and that I think almost everything we learn in dogs will be applicable to cats.
Can you just real quickly, because it's come up so much, give like the layman's of what rapamycin is for listeners just before we send off, because it's come up quite a bit.
Sure. So rapamycin has kind of a cool backstory. It was discovered from soil samples on Easter Island, which is also called Rapa Nui. That's where the drug gets its name from. It was originally developed as an anti-cancer, antifungal drug, but then came into clinical use in organ transplant patients to prevent organ transplant rejection. And that's sort of unfortunate in some ways. I'll come back to that in a second, but that's how it was first approved by the FDA, was to prevent organ transplant rejection in organ transplant patients. And that's how it's mostly known today. It's approved for some other things, but it's mostly known as an organ transplant drug. The reason why I said that's sort of unfortunate is because in that context, in people who've had an organ transplant taking immunosuppressants, they take rapamycin at high doses, there are some side effects associated with the drug. So it kind of got a bad reputation because of the way it was developed. In parallel, when I was a postdoc, myself and several other people sort of at the same time all discovered that rapamycin could impact the biology of aging in a bunch of different animals. And it does so by inhibiting a specific protein called mTOR, which stands for mechanistic target of rapamycin. I won't get too far in the weeds, I promise. The way to think about mTOR is sort of a key sensor that every animal cell has that senses the environment, particularly nutrients, so food, and helps the cell make the decision: should I grow and reproduce, or should I shut down growth and become stress resistant? When there's lots of food around, you want to grow and reproduce. That's a good time to have babies. When there's not any food around, that's a really bad time to have babies. And so mTOR shuts down growth and reproduction when there's not very much food around. And that causes this long-lived stress-resistant condition. Rapamycin kind of tricks the cell into thinking there's not much food around by turning down mTOR. And so what we have seen now is in every animal where this has been studied, it increases lifespan. And to the extent we can look at health span, seems to improve pretty much every health span metric that can be measured. So if you think about mice, they get many of the same age-related functional declines and diseases that we do. And rapamycin has been shown to at least slow down many of those. And I think what's most exciting is in at least 4 cases now, you can take an old mouse, start giving it rapamycin, and see improvements in tissue function or organ function. That's true in the brain, it's true in the heart, it's true in the oral cavity. So we published from my lab, we could reverse periodontal disease in old mice with rapamycin. And it's true in the immune system. You can actually take an old mouse that doesn't respond to a flu vaccine anymore, you give it 6 weeks of rapamycin, and it will respond just like a young mouse. So you can rejuvenate the ability of the immune system to respond to a flu vaccine. So it seems as though it can improve functional deficits.
So in terms of aging, basically, and I'm assuming this is also true for humans, it's reducing the mTOR growth.
Yeah, it turns down mTOR. That's the biochemical mechanism. In terms of what it's doing, from a more pragmatic perspective, that's harder to answer because there's probably multiple things. One of the big effects of rapamycin, and this is why it's useful as an organ transplant drug, is because it's very potent at turning down certain types of inflammation. So inflammation is just activation of the immune system, right? And you don't want the immune system, if you're an organ transplant patient, activating itself against your new organ. So it turns down inflammation. The thing that's interesting about rapamycin is it doesn't seem to be as general and anti-inflammatory as some other anti-inflammatory drugs. And this is my speculation as a non-immunologist, but it seems to me that it's very potent at turning down the types of inflammation that seem to accumulate with age. So every human being, every dog, every mouse has an increase in what people call sterile inflammation. And that's the immune system reacting against things that it shouldn't be reacting against. So sterile means not a pathogen, not a bacteria. And some of that is reacting against self. So that's where autoimmunity comes in. And rapamycin just seems to be pretty good at knocking down that sterile inflammation.
All right, one more stupid question before you go, Matt, and then I promise that's it.
I haven't heard a stupid question yet. Come on, you keep promising me one.
Do we still get all of our rapamycin from Easter Island, or is it created in a lab now?
So I won't say that was stupid, but
it was stupid adjacent.
No, the answer is no. Although it is interesting. So rapamycin still, it can be made in the laboratory, but it does still have to be made in what are called bacterial fermentation. So it is a very complicated molecule. It can't be made just by straight organic chemistry.
Oh, we just did an episode on fermentation, Matt.
Yeah, so but it is now produced in not a lot of facilities around the world. So here's my stock tip, which don't take stock advice from me, and I actually don't know of any stocks. But if I had money to invest, and so if rapamycin does in fact turn out to slow aging in dogs and slow aging in people, there's only like 5 or 6 places where it's made around the world. I think there's going to be a supply and demand problem for rapamycin. So if you have an opportunity to, invest in a new rapamycin production facility, maybe that's where you want to put your money.
Okay. Well, sir,
fantastic.
I can't thank you enough for giving us your time and letting us pick your brain. I could literally talk to you all day about this stuff.
I know. Thank you. It's I just want to keep asking you questions. Really appreciate your time and your awesome answers. Thank you.
Yeah, my pleasure.
Before we go, is there anything that, is there a milestone that you want people to know about with Dog Aging Project that you're trying to reach that they can help with?
Yeah, I mean, so the one thing I would say is right now the Dog Aging Project is actively raising funds for sort of a bridge period between NIH funding. So if people are interested in philanthropically supporting the project, there's a Dog Aging Institute. dogaginginstitute.org. It's a 501c3 or will be soon. Please, we would be grateful for any support that people would like to give the project. And like I said, we are continuing to enroll dogs. We would love to get this project as large as we possibly can. So if you have a dog and you want to support science or dog health, or you just love your dog, please consider going to dogagingproject.org and nominating your dog to participate.
You will have 3 new nominations after this call, Matt.
Awesome.
I really wanted to get specific. I know I kept interrupting him. He was so cool, right? He's like, I'm going to answer this question, then I'm going to answer. Like he was so giving. He was willing to specifically answer each question. Here we were like a couple of clowns.
I know. He called us out for bouncing around all over the place. He's like, damn, man.
Continually interrupt him.
No.
He wasn't wrong.
To him, he's been studying this so long, but everything he said was so fascinating. I wanted to branch off and find the next fascinating thing.
That's what it was. I wanted to go, okay, no, but can you talk more specifically about A, B, and C? But, it's so funny. It's true, it's the 4 things: connection, sleep, exercise, and diet.
Yeah. Don't eat like a shithead, which is a problem for me.
I think it's a problem for most people, don't you think?
Yeah, I do agree. Yes.
And the other thing that I really like that he said is it's not one size fits all. Which everybody that has a specific diet will say this is the diet. But I appreciate that he said, you've got to experiment and find the thing that works for you, including take the reins of your own health and don't be depending on doctors or, sort of become interested in your own health, which I thought was great.
Yeah. And I've had a friend my whole life who is on the shorter stature side. And I know it used to bum him out, but now he should be pretty psyched. He's going to live longer than the rest of us.
Short people got no. Yeah, man. So there's hope for us all.
Mm-hmm.
This was great. Yeah. I hope you guys enjoyed it. Look into this guy. He's fascinating. He's got some podcasts that he did. He's got a lot of answers. So if you want more of Matt Kaeberlein, please find him. All right. Thanks for listening.
Music by Denny Nucci. Produced and edited by the same 2 people you heard hosting this show because they have no friends.